Yeah. I asked your friend to turn off this, he turned it off on. Huh? Don't blame me. I'm not the one. Hope you have a presence of mind and find a bench you are sitting. That's find a bench you are sitting. You understand? Have some decorum, man. I have decency. Be cultured. Settle down. You take your time. I'll take my time. Decide yourself. I'll do it. Take your time. Settle down. I don't have any hurry. No, you don't have any hurry. If you are ready, you tell me. I'll start. Shut the door. I'm closed. Ready? Yes. Given reply for basic also please. Yes, over. Oh. Now, we'll start. Very good morning to one and all. So, we'll start with the module 3. We had started with the module 3. And we started learning what is idealization, system of forces, then superposition, transmissibility, resolution and composition of forces, then law of parallelogram of forces, resultant of concurrent and non-concurrent. Non-concurrent, we have not yet started the forces. What is a moment of force? Then what is a couple? Till here we have completed. Correct? And don't think that I'm waiting for my IA to prepare. Immediately one day I'll announce class test. Class test. Don't wait for IA. So keep on preparing. One good day in the class, I'll announce the class test, and that class test has an equal weightage on your internal marks. Okay? Is that clear? Don't fold your hands and relax. Okay, chalo, my IA is little away. I can rest. No. You have to equally prepare for the class test also, which may announce at any time in your class hour. Okay? Now, we'll start with the Varigno's theorem. I said you go according to your syllabus. Any subject, you keep your syllabus and prepare as per that. Okay? Now, what next is Varigno's. Not working. Okay. Leave it. I don't know any problem must be there. Start the next. Line knots. You can join on this link also. Online link. Diagonal theorem of forces. Line knots. Theorem of forces. Why is it required? Because we study law, parallel and law. Right. Only to find the percent of all the forces. Now we have to know forces present by the there are things introduced only to calculate the resultant of the forces. So how to do it? What it is? Variable theorem. And there is a concept of it. It is nothing but let's say there are number of forces as F1, F2, F3. It is coplanar, not coplanar it is. Okay, I was talking about this. You find number of forces. Here, you find number of forces F1, F2, F3, etc. Many forces. So not meeting at a point or some meeting at a point. In this case, we are showing that all the forces are meeting at a point. P1, P2 are the two forces which has been considered. And we have to calculate those and I'm not applying the backwards. Here, right? That is the result. How to go about it? So I am starting to line marks here. So what it is telling that, look here, stop murmuring man. It is telling that I will be calculating the resultant of this force. I am calculating the resultant of all the three forces. Right? That I will be calculating the forces, I will be calculating the resultant. So I will be calculating the resultant at a particular point. Let me say this at point A. Okay? That is I am calculating RA. Okay? Similarly, I am calculating the force F1 at A, force F2 at A, force F3 at A. So I want to know what is the effect of force F1, F2, F3, and what is the resultant. Resultant is also a force. It is not something resultant. It is a combination of the combined effect of all the given forces. Now, how do I calculate? How do I find out what is the Parito's theorem telling? It is telling that you take the effect of all the forces. Now I am putting a point as A. So I am center point is at every point I am taking as A. Right? Take the moment of all the forces. So F1 into X1. Let me say this is one day and your F1 is here and your F2 is here and your F3 is here. Let me say as X1 distance, perpendicular distance. Okay? By geometry somehow we calculate and this to be X3. Correct? So I calculate F1 X1 plus F2 X3 for X2 plus F3 X3 is equal to as the Parito's theorem is knowing that it is equal to the effect of all the three forces will be as resultant. And even this resultant, when I take the moment of this resultant about one day, let me say it as capital X. perpendicular distance of vector x. So which is equal to r into x. So Weierstrass theorem is about the moment of all the forces about a particular point is equal to the resultant of the same system of forces about the same. That is the gist of it. So, which is nothing but, it has been told here, this is also known as principle of moments. The theorem states that the algebraic sum of moment of individual forces about of a force system about a point is equal to moment of all their about the same point. Got it? This is what, and this derivation is very important. You have to do it. This is a regular question asked for 10 marks in every question paper of VT. Okay? Now please make a note of this statement, which is also called as a principle of moments, and the algebraic sum of moments of individual forces. You saw here I'm taking the moment of individual forces. What is individual? F2 is an individual. To which I am telling that it is a moment of the resultant about the same point. About the same point. And there are certain questions, right? State and rely. State and rely, right? Not theorem. Right? Theorem of moment. Right? Sometimes what happens, you don't give the statement. And you forget to start derivation because of the value of time. Right? And you may lose 2 marks there and you don't give the statement. Okay, did you follow? I'll repeat once again. I'll repeat for your understanding. I take 3 forces, right? I take 3 forces, F1, F2, and F3, and see to that they meet at a point as point A, and perpendicular distance has been calculated as x1 by geometry we calculate the perpendicular distance x2. This has to go with this, and this is x3, right? So I say f1x 1 plus f2 x2 plus f2 x3 x3 is equal to resultant of all. Resultant how do I get? Coming up f1 plus f2 plus f3 depending upon the direction. If it is resolved, you have to resolve. This is only for your concept understanding. Resolve and find out. So it will be r into x about the same point at point A. Now look at the figure. Don't start doing all this. Please look to the figure. This is only isometric view. You need not draw this. This is, I have taken this image only for your understanding. Okay. Actually, you are supposed to draw in your book this diagram. What is this? It is telling us a coplanar concurrent force system. What is coplanar concurrent force system? It is P1 and P2. You find P1 and P2, 2 forces. They are meeting at point. Some common point as, let me say it as A. Okay. Look to the diagram here. Everyone stop writing there. Look to the diagram. P1 and P2 are the 2 forces what I have taken for the force system to analyze or to prove Weierstrass theorem. Okay. Now I'll find the resultant. Resultant eventually we take it as a diagonal. If I complete as a rectangle, I'll take it as a diagonal. Correct? So I represented R. So I represented as R. Do you agree? Did you agree? Yes. So P1 and P2 are the 2 forces which are meeting at point O or point A, whatever you consider. And the resultant is given by the triangle. So the rectangle, when I complete this rectangle, the diagonal will be the resultant. Okay, I represent R. Now, for our imagination, you think it as an isometric view. Which I could not draw here, I am drawing here. The same. Now, P is a point which is in the space. Isometric. Now, I put P1 as a perpendicular distance for P1. What I tried to do it was not visualized here. I am making you to visualize here. Perpendicular distance. Moment is always force into perpendicular distance. So for P1, I want the perpendicular distance. P1 is a perpendicular distance. This is making a perpendicular distance in point B. With point B. B, you think about 2 forces, P1 and P2, and you have a point B here in the space, and you have to measure the perpendicular distance from the force P1 and P2. Okay. Now, similarly for P2 also, I have taken the distance as D2. Yes, P2 and D2. For P1 it is D1. Similarly, I have to calculate the resultant perpendicular distance, which is nothing but D. Which is nothing but D. Yes or no? You're following or not? Right? So B is a point. I have to know what is the moment. Right? What I have taken as A here, the same thing I'm taking it as a point B. Okay? Now, instead of drawing this, I'll draw this as a, you have to draw this diagram. The same thing, I'll put it in a X and Y, XY axis, in a planar. It is a non-coplanar. It is a coplanar, right? So, I've shown this as X axis and this as Y axis. Correct? X axis you can see and Y axis you can see. Where is P1? P1 is here. Where is P2? P2 is here. Look to the diagram. And see the angle theta. What is the angle theta? It is representing the resultant. Resultant R. Right? The resultant R is between P1 and P2. And what is the resultant at an angle of theta with respect to X? With respect to X. Okay? We are projecting everything in XY axis. XY axis. I am bringing down into the XY axis because we are working on a coplanar system. Okay, now theta. Then what about the B1? B1 is here. Sorry, B1 is here and P2 is here. B1. So what is B1? What is B1? The point here, which I have shown as B there, has been moved on or located on y-axis as B. It has been moved or located on y-axis B. By geometry, you find B and B1 are the perpendicular distance for the resultant. For the resultant, you show no here. What is the resultant for it? B was a perpendicular distance. But here, B1 and B will be the resultant. That is equal to D. And by geometry, we get this angle B1 as theta. Okay? So you need not draw this diagram. You have to draw only this diagram in your book. I'll repeat. You can start drawing also. X and Y axis you have to draw first. Then you have to draw P1 and P2. Then you have to draw the resultant. Then you should show that resultant is at an angle of theta with respect to X axis. Then you have to represent the perpendicular distance only for the resultant. Only for the resultant. And B and B1 as a resultant distance, perpendicular distance as B, which is making a geometry as theta. This is and this theta remains same. Please draw the diagram now quickly. Go with the free hand sketch. No need to use here and now. You can go to the free hand sketch. You need not draw this. You have to draw only this. Read the lines above also. You can read. Let R be the resultant of forces P1 and P2. As simplified for 2 to write down as it is. In textbook that you will lengthy long way. You have to write this more than that. So write down vegetarian practice this at 5 times. The regular person. Okay. Now you understand. Let R be the resultant of forces P1 and P2. Yes or no? By the diagram, you see that it is the resultant forces of P1 and P2. Let P1 and P2 be the moment force of the forces R, P1 and P2, respectively, from the moment center point. Center point. That is doing writing. increase the speed, no, that it's not, huh? But it is not reaching them. Yeah. Over. Next. Now, next comes to look to your book. What is the diagram you have drawn? Relatively, you check the equation. R into D. R into D is what? R is the resultant. D is a perpendicular distance. Can I write it as R into AB cos theta? Can I write, check the triangle? R into AB cos theta. Will that go? AB, you understand what is AB? AB you find here. AB is a hypotenuse. You agree with that? Yes. So I am defining D in terms of AB cos theta. I can write D in the form of, in the triangle. A, this is B and this is E1 and this is theta. Now to get theta, this is hypotenuse. This is perpendicular. Correct? So now how do I put the D value? What form? Cos theta is equal to, cos theta is equal to by A. Or B is equal to AB cos. That is what I have done here. That is what I have done. Nothing, no magic. If I say this has magic in this class, they'll laugh, man. We have learned long time back. Proceed. No, leave your hand from your chin. Don't rest. Start doing next step. Then I call it as AB as what? What is AB in your diagram? AB, I move it. AB into, I reshuffle, I rearrange. AB into R cos theta. Correct? Yes or no? I just moved. Then, what is R cos theta in your diagram? R cos theta. Where is R? This is R. Cos theta. This is, I am resolving. I am resolving R along cos x. Please here. R is at an angle of theta. I am resolving R cos theta. Means what it will become? Rx. Resolution. I am resolving this. If I am resolving to the vertical, it will be R sin theta. Then it will be Ry. Now I am resolving along x-axis. R cos theta is representing Rx. So this is Rx. What is Rx? It is nothing but resolution of R about x-axis. About x-axis. Now, as I did for R, similarly I can do it for P1 and P2, isn't it? So P1x is equal to what I get? After I skipped one step there, I didn't write all that. I directly put as P1x and P2x. What you got it as ABRx. I directly skipped one step and wrote it as AB P1x plus, sorry, and P2 D2 is equal to AB P2x. Now I call this as equation 1, equation 2 and equation 3. Did it follow? Same, whatever you do the resultant, same thing you do it for P1 and P2. Right? So I can write, instead of doing all that operations steps once again, I can write it as similarly P1 D1 is equal to AB P1x, P2 D2 is equal to AB P2x. So now add equation 1 and 2. Sorry, 2 and 3. What do you get? Adding two equations. Adding adding two steps, two equations, you will get that P1 D1 plus P2 D2 is equal to AB RX. That is what we did here. I said this is the final equation. This is what you are getting here. Further I can X component and Y component we can generalize as R into 3 is equal to P1 D1 plus P2 now 5x time I give 5x after 5 minutes you go to 5x. Got this one. 5 minutes you have to go this. Statement and the code. After 5 minutes I will use this. It's very important theorem. I cannot give up. You have to learn. 5 minutes time, only 5 minutes time I give you. Now the time is 11:40. 45 and start announcing this on the same thing. But 5 minutes don't you can do. In 2 minutes, I'll finish the attendance. Malad, Madam is doing, I can simply sit under the fan and enjoy. Huh? Gulwar, Scott, huh? The many words in the class, I make work, study it, because I have to do it. It's very difficult. You have seen formulas, right? How do they make them to do it? Right, and I can give. The attendance. Ashta, Ina, Market. For attendance, attendance, get it. Nasama. Aditi, Aditya, Akash, Sana, Satake, Akshay Gowda, Nanya, Nanya, Nayati, and all my class. Oh, you know. So all I want is what are we to say? Amen. Hello. Those who missed the first two classes now, first and taking now the third class. Ashita, Abel Mohan, I Dora, I Suman, I say, over fellow, I can't. Over? Yes, you can solve it on the board. The green shirt. Can you do it on the board? Next we'll learn about the memory bank. As per your syllabus, memory diagram is very, very important. Something that in your mind now and happy with that. That is required. Otherwise, you go into the what the government stage. Now let's start the defining memory diagram. Transform and transform. And memory diagram is after this was a problem, right? After we have here, with a rope, and in a rope you always take a tension. And the same thing, the mechanics of the force applied on the roller is being shown with the free body diagram. Okay, so you need not write this, it is available. Only I made you to practice about the Marigol's theorem because it is important, it is available. And this is a diagram you have to show in the given problem, right? It's only a representation. As a line diagram, you have to represent the given force system. This is not there, Lam's theorem is not there for you. Yes, this is the last topic of your module 1. After this, we start only problems. Equilibrium. Equilibrium, I say, I am under equilibrium, law. Equilibrium tells us law stable, rather. Law stable, right? Equilibrium is law steady. You can take up all the forces coming on you. Even I put a 10 kg of load on you, you will be stable. That is not also. Why? Because the other is ready to take the load. Your knee is taking no vertical force coming on it as equal to 0. Right? That means when a stationary body is subjected to extra force and if the body remains as rest, it is said to be equilibrium. That's now what the example I gave of Mr. Yadav. You understand? Carry 10 kg of bike, so you will be sitting. If I increase to 20 kg, you will be steady. But after some time, if I increase to 50, you will not be under steady condition. What happens? You start moving, falling down. You will not be going across the steady position. It will go disturbance. Right? You will not be having a constant steady position. So that's what we put it in a like this way. But actually, we define it in a one second. You read this.
ಹಲೋ,
This call is now being recorded.
ನಮಸ್ತೆ ಮ್ಯಾಮ್. ನನ್ನ ಹೆಸರು ಪ್ರಿಯಾ ಅಂತ, ನಿಮ್ಮಲ್ಲಿಂದ ಮಾತಾಡ್ತಿರೋದು. ವೆಹಿಕಲ್ ವರ್ಕ್ಶಾಪ್ ಬಿಟ್ಟಿದ್ರಲ್ಲ ಬಾಡಿ ರಿಪೇರಿಗೆ, ವೆಹಿಕಲ್ ಡೆಲಿವರಿ ಆಯ್ತಾ ಮ್ಯಾಮ್?
ಇಲ್ಲ ಮ್ಯಾಮ್. ಇದೇನಕ್ಕೆ ಹೇಳಿ ನೀವು ಫೋನ್ ಮಾಡ್ತಾ ಇರೋದು?
ವೆಹಿಕಲ್ ಡೆಲಿವರಿ ಆಗಿದ್ರೆ ಫೀಡ್ಬ್ಯಾಕ್ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ.
ಹೌದಾ ಮ್ಯಾಮ್? ಇನ್ನ ಆಗಿಲ್ಲ ಮ್ಯಾಮ್. ಈ ತರ ಕಾಲ್ ಮಾಡ್ಬೇಡಿ, ನಾವು ಆಫೀಸಲ್ಲಿ ಇರ್ತೀವಿ, ಮೀಟಿಂಗ್ ಅಲ್ಲಿ.
ವೆಹಿಕಲ್ ಡೆಲಿವರಿ ಆದ್ಮೇಲೆ ನಾನು ಕಾಲ್ ಬ್ಯಾಕ್ ಮಾಡ್ತೀನಿ ಮ್ಯಾಮ್. ಥ್ಯಾಂಕ್ ಯು ಮ್ಯಾಮ್.
Okay. Now, actually, principles of equilibrium or equations of equilibrium, or there are many other ways. When equilibrium comes into picture, there should be 3 equations coming into your mind. Sigma fx equals 0, sigma fy equals 0, and sigma m is equal to 0. This is only for equilibrium. Madam, yesterday you wrote sigma f is equal to some equation you wrote. Today you are telling that sigma fx is equal to 0. Don't get confused. When we are talking about the equilibrium, we talk about these equations. When we are talking about the force system, we talk about those equations. Okay? So this is very important to make a point of it. Equations of equilibrium is summing of all the forces equal to 0. That means your friend, whoever it is, if he is weighing 60 kg, he can take up a load of 60 kg. So 60 minus 60 goes as 0. Like that. Did you understand? Now you are sitting there, comfortable, it is not falling down, right? It is under equilibrium, right? Because the weight is ready to take up your load. If instead of like 5 are sitting or 6 you are supposed to sit or 7 it will increase. What about the load? The load will increase. What will the weight will take? No, it will fail. It will not be equal to 0. It will be minus. It will be more than that. So the equilibrium condition has to be maintained. Given by the condition as sigma fx is equal to 0, sigma fy is equal to 0, and sigma m is equal to 0. Okay? This is a coplanar concurrent fixing. The problem, this has been done? No? Yeah, take this problem.